This is a bonus video on vectors. It's going to look at one type of problem that we really haven't touched on yet with all of our vector problems, and it's probably a little bit more realistic. So let's just look at what we've looked at so far, just kind of in a diagram. To this point we have said, well, there's a wind going 75, 100 miles this way, and our airplane is going this way. And the question will be, where does the airplane end up? Pilot jumps in the plane and says, we'll just go wherever the wind takes me, and then we would construct our parallelogram and say, well, the wind's going that direction, or the airplane's going the blue direction. However, that's not very realistic. In the real world, many times what happens is this. They say, well, we know where the wind is. That's the purple there. And we know which direction we want to go, the blue. The question is, what direction and speed do we have to go so that the wind blows us in the correct direction? Or think of a ship in a current. They just don't go out to the current and say, we'll just go where we go. They figure out where do we have to go so that the current pushes us to the correct place. So it's a little different now in how our diagram is. We have one side, so when we make our parallelogram, we have to reconstruct the parallelogram because we have the diagonal. Then we have to reconstruct our two sides to get our diagram. So let's look at an example. An airplane wants to fly on a course of 140 degrees at 250 miles per hour. There is a tailwind of 75 miles per hour from due west. What direction and speed should the airplane go to get the correct direction and speed? Well, based on my diagram here is the 140 at 250, which is this red vector. It's 140 from due north, so we know that this angle here is 50. We have a tailwind of 75 from due west, so this right here is 75. Now, we cannot just take this, create our parallelogram here and go forward, because the red line is our resultant. That's the way we want to go. So we need to reconstruct our parallelogram. Put the 75 down there, and I already have this ready to go, and create these pink sides to get our parallelogram. So now the question is, what is this angle? What is our speed and direction that the plane should go so that the wind blows us on the correct heading? Well, we can do that with law of cosines. 75 squared plus 250 squared minus 2 times 75 times 250 times the cosine of 50 would give us x equals, and if I do that on the calculator, I get that. 209.81. The other thing I got to figure out is the direction. I got to find this angle right here, theta. So I have the sine of theta over 250 equals the sine of 50 over 209.81. So let's do that. We have 250 sine of 50 divided by 209.81. Forgot the division there. Then I do inverse sine angle, and I get 65. Now, my angle is very much to scale, so I realize, if you remember, those of you that looked at the law of cosines, we have an angle. You never want to find your largest angle with the law of sines, which this is our largest angle. So one thing to do would be to find this angle over here first, or realize this angle is bigger than 90. I'm going to subtract that answer from 90, and then I'm going to add that to 90 to get my answer. So my theta is 114.71. So if I want to figure out my direction and magnitude, it's 209.81 miles per hour. And then it's going to be south 24.11 degrees west. And I just kind of cheated there and said, okay, if this is due south, how far over do I go? So these problems, we're going to have to find our angle and direction to end up where we want. Now, another way we could do this would be to say, let's do it with components. I could look at my plane, and I could do 250 cosine of 50 and get 160.69 or 770. And then I can do 250 sine of 50 and get 191. Now it's negative 191.51. You can get that from your diagram. You can see it's positive x, negative y. And then we have our tailwind, which is 75, 0. Now, I know my answer I have to add together. So I'm going to say, let's call it the current vector. Which way should we go? So I'm going to call this x and y. And I know x plus 75 has to be 160. So I could do 160.7 minus 75, and I get 85.7, excuse me. And I know this is negative 191.5 since it's 0 here. So this is my correct speed and direction to go 140 at 250. Now I need to convert this back so we can do, I can do 85.7 squared plus 191.15 squared. Take the square root of that. Try again. 85.7 squared plus 191.15 squared. Hit enter. Take the square root of that. Let's try again. Take the square root of that. Try again. Take the square root of that. And we get 209.81. Notice, same answer we got over here. Now, if we wanted to find our direction, we could do inverse tangent of negative 191.51 divided by 85.7. That gives us our negative 65. That is our answer right here, negative 65. So that would be east 65.89 degrees south, which you can see these two, this should be, sorry, this right here should be east, shouldn't it? South 24.11 to the east. So you can see two different ways of doing it. The key is, though, you are given the direction you want to go, and you got to determine which way will get you there at the end.